all of them already. And we've just started recording. Ladislav started recording, so I hope no one has a problem with that. So my name is Vladislav Matus, and I'm an organizer or co-organizer of Golang Meetup. And I'm here with Ladislav, who is another co-organizer, and with our wonderful guest today, Jon Calhoun. So let me just welcome you, Jon, and say a few words about you. I hope I won't be saying anything that you don't want to hear. So Jon is a full stack web developer, and he teaches about Go, about web development, about algorithms, and basically anything programming related. And he also consults for other companies. And of course, he is co-founder of EasyPost, which is a shipping API that many Fortune 500 companies use, which is, I think, it's very cool. And he has worked in Google in the past, so he's a great guy. And he is an author of Go for Sizes as well. Some of you might know it, or at least I will do some advertisement for that later. So I hope you will know it by the end of this meetup. And he's an author of multiple other courses in Go. And I'm really glad that he joined us today. Welcome, Jon. Jon will today have a presentation about journey before destination, how we can learn programming languages. So the floor is yours, Jon. Welcome again.
Thanks for having me. I guess this means I need to stop your screen sharing. Is that okay?
Yes, I will stop my sharing and you can take it over.
All right. So today's talk is titled Journey Before Destination. A lot of you, if you read fantasy, will probably recognize this. It's a phrase repeated pretty consistently in the Stormlight Archive book series written by Brandon Sanderson. So in the books, it typically refers to morality. Basically, leaders get so focused on some end goals that they take part in immoral acts trying to achieve those end goals. So the phrase is kind of a reminder for the characters in the book that how they get somewhere is more important than the destination itself. Some examples of these might be people trying to win a war and then like committing war crimes of some sort. So the goal is to sort of remind the characters that how they're getting where they're going is more important than actually achieving that end goal. So as I read the books, the whole series isn't done, but as I've read them, the phrase constantly made me think about how people learn to code. Rather than looking at it as this journey that they can make the most out of, people will try to take these shortcuts. They'll try to jump to the end and they don't quite realize how this can negatively impact them. So in today's talk, I just want to talk a little bit about why I believe that's a mistake and some ways to sort of make that journey more productive and more enjoyable as you're learning to code. So a little bit about me. Sorry, I'm at the end of my slides. So a little bit about me. I am Jon Calhoun, as Ladislav said. I'm a panelist on the Go Time podcast, and that's a podcast where we talk about all sorts of things related to Go and try to teach people something new every week. I also create Go courses. Go for Sizes is the one that most of you have probably heard of because it's free and it's kind of like an easy one to pick up relatively early when you're learning Go. I also write a Go newsletter, and this just is little pieces of advice or little lessons that I think I can send out to people once a week to help them learn something new in little bite-sized chunks. I also have Go tutorials on my website, and I'm constantly working on new books, new courses, and more. So you'll usually see new stuff from me, both paid and free stuff coming out relatively frequently. So in short, I teach a lot of Go. I help people learn in a lot of different ways. And this also means that I've seen people make pretty much every mistake you can make. And that's where a lot of this advice in this talk comes from. So I want to start by saying that I get that learning to code is a means to an end. I'm not here to try to tell you that it isn't, or that you should only do it if you enjoy it. I realize that some people really love coding, but more often than not, people get into development because they need a way to earn money and to pay the bills. So as a result of this, it's really tempting to try to skip to the end, to try to just skip to those skills that are going to get you paid, the skills that are going to stick out on a resume and help you get hired. So what this usually translates into is people want to build modern web applications and they don't really care about what they feel are outdated ways of building them. They don't want to learn why things have changed or where those outdated methods might actually make more sense. They just want to jump to what they think is modern. Another common one is people want to write clean idiomatic code, and they don't want to bother learning how to refactor or writing the rough version first. And this is a really common one. And I think what a lot of people miss with this is that almost every developer I know ends up writing the ugly version first, and then they learn how to refactor. So writing clean idiomatic code is something that everybody has to do through a refactoring process rather than just something they do instantly. Another example is that people want to know how to structure their code like they do at Google or Apple or whatever big company they want to get a job at, and they don't really want to spend time learning other ways to structure code or why one way might make a better fit for a Google or an Apple, but it doesn't make quite as good of a fit for personal projects. So in short, as I said before, they just want to rush to the skills that are going to help them get hired. So I think it is a mistake to rush to the end. Now, I know this is somewhat counterintuitive. A lot of you are probably thinking, if I'm going to use these skills on the job and I know I can learn those skills now, isn't it best to just focus on learning that technology? Whether it is microservices or Docker or whatever other technologies you're thinking about, it's really tempting to think that if those are going to be the things that I see myself using on the job, shouldn't I just focus on those and not worry about everything that came before that? And I actually say that no, it's not best to start with those things. And the biggest reason for this is that you can't write the code that you're going to write in 5 years from now without the experience that you gain along the way. And rushing to those technologies doesn't replicate that experience. More often than not, it just skips it entirely. So you miss out on all these chances to learn why things have evolved or different ways that things have changed and how different approaches work in different scenarios. And this is a big mistake. Sorry. You need that knowledge and the experience of writing what I'm going to call bad code. It's not really bad code, but you need the experience of writing that initial code to understand why the refactored version is clean, good, clean code, and whatever you want to call it, idiomatic, clean, any of those terms. Another thing is whenever you're doing different code structures, you need to sort of write code with what is maybe not the best code structure to then come back and understand why a different code structure fit that project better. And oftentimes without seeing the two to compare and contrast, you don't really understand the benefits of what is the good structure. Another example of this is attempting to test untestable code. If you've never had untestable code, you probably don't really know what it means when somebody says like it's untestable or it's hard to test. But if you write some code that's really, really hard to test and then you go try to add tests to it, you'll quickly understand why doing things one way can make it way, way easier to test. So rather than rushing to the end, we should instead focus on things like making learning fun and productive, understanding these trade-offs as we go, and building lasting skills, not learning specific tools or technologies. So that's the goal of this talk. And we're going to first start by saying that you should try to find something you enjoy working on. This one's a big one for me because I see a lot of people that basically take this route where they make learning to code suck, and it really shouldn't suck. When you rush to the end, it kind of feels like you're playing a video game where you're playing the same level over and over and over again, trying to master it. And at first it might be fun. You enjoy this game, you enjoy this level, but it quickly becomes really tedious because you're just doing the same thing over and over again and you want to quit. And if you are rushing to the end and just trying to get to the technologies you see yourself using, you aren't doing something you love. Instead, you're just basically grinding like you would in a video game, and it can be really tedious. So if you go ask others how they've learned, just for some ways to contrast this with what you might think is the best route, chances are they won't tell you about a sucky grind. They won't tell you about, going through a bunch of courses that they hated. They won't tell you about banging their head off the wall. There might be some stories like that, but most of the stories I hear are not about people pushing through this awful grind of going through courses or tutorials and forcing themselves to learn these skills and doing projects they don't enjoy. Instead, what you'll usually hear is somebody who started off with some hacky little project and maybe they didn't even have a plan to be a developer, but that project inspired them to continue learning more about programming and they ended up spending countless hours with it. And before they knew it, they're a full-time developer. For instance, I know people who started by scripting levels in video games. And then as they were building these little levels, they wanted to expand them a little bit, make them a little more interactive. So they started learning how to code a little bit more instead of just being a, if the user has this item, do this thing, otherwise don't. They started adding interactive scenes, or they started like adding more little scripts to it to try to make the levels more complex. And eventually they get to the point where they're basically programming and not even realizing that's what they're doing. And they eventually become a professional programmer of some sort. Another example of this is I saw somebody who was learning to build just a simple website to host their band's music. And this was a while back. So as they were trying to spruce up the website and make it a little bit cooler, they wanted to learn Flash. And that was the cool way to spruce up the website. So any of you who are learning now might not even use or know what Flash is. Hopefully you do. But it was this older technology that you could use on the web, and you could add all these cool animations and do things like that. And it required some scripting and some coding to make it work. So people would start doing this, and then eventually they'd find themselves diving into web development and becoming a developer. And there are tons of other similar stories to this, and they're almost all focused on a passion project. They're not somebody who was like, I'm going to learn to program, and they sat down and did it. It's not that that's an issue, but almost everybody who succeeds does so with a project that they really enjoy spending time with. And I think this is the case because when you're doing something you enjoy, you're going to be more productive with it. You will sit there and code for longer hours. You won't give up when you encounter a bug. And even if you're tired or it's the end of the day and you just want to relax, a lot of times working on that passion project will be how you relax rather than sitting down and watching TV or doing something else instead. So the people who are working on these passion projects are a lot more motivated to stick with it. And the end result is that they get a lot more hours in of practice and coding than somebody who's just going through a grind. So the end result is that while these passion projects might not teach you these specific skills you expect to use on the job, they will teach you general skills that are going to translate across any programming aspect. So whether you're doing web development or you're programming video games or something else entirely, it doesn't even matter which languages you're using usually. As long as you are learning these general skills, they're going to help you translate them across different tech stacks, and you'll be a good developer in the end. So with those skills, you can then learn the job specific things that you need when the time comes and you're applying for jobs, and this will help you find that job that you want at the end. The next piece of advice I have is to be open to exploring other topics and areas of just programming or tech or anything like that to try to find that passion project. So for many of us when we're starting, we might not have that thing that we want to work on. So it's very important to explore and figure out what actually grabs our interest. So US universities actually do a pretty good job of this, I think. They're designed so that students can change their major within the first couple years without major setbacks. Now, there's lots of other things we could talk about with universities, but that's one of the things that they do very well. So if you are studying math, and while you're doing all these math classes, you also take a couple computer science classes, and you realize that you really love computer science, it's usually not much of an issue to switch majors from math to computer science of some sort. Or if you're a CS major and you realize that you love physics and you want to build rockets, you can do that too. So there's all sorts of ways early on that you can just sort of spread out, take all sorts of different classes, and figure out where you want to focus towards the end of your university studies. So this wandering should also be encouraged when learning to code. When you get hyper-focused on this end game of these are the skills I need to learn to get a job, you don't explore other topics. You don't find out what you actually love. And you might find yourself learning those skills, but then having a job that you hate and not really wanting to branch out into the things that you really love. And this is a bad thing. So as I said, you learn by doing what is interesting to you, and exploring and wandering with different topics is going to help you discover that. So whether it is somebody who thinks that they're going to be building backend services, and then they start messing around with UIs and building HTML pages, and they really like that UI UX interaction and the instant feedback from seeing stuff. So then they might become a front-end developer. Or maybe it's somebody who really thinks they're going to do front-end work, and instead they find themselves working on DevOps and making that server ultra resilient so that thousands of users can suddenly hit the page and it stays up. and they might find that that's the route they want to go instead. It could be security or anything else. There's all sorts of different sort of areas of specialty that you could look at, and you should be trying to explore them to figure out where you actually get the most enjoyment. Now, I'm not saying you should try every language under the sun or that you should try every database or every technology out there. It's the same as sort of at a university. You eventually have to settle down and pick a major. You've only got so much time to sort of explore different topics. So you should do this, but do it within reason. You eventually need to focus on something if you want to get a job and move forward and, go forward with your career. So this next one is to learn about alternative approaches. In this one, I'm going to show you a code sample, but if you don't understand it, don't worry about it. This is more of just an example of something for me that allowed me to take something I learned in one language, and it really helped new techniques coming out in another language really sink in for me. So when you're hyper-focused on the end game, you usually don't learn about how other technologies do things. So if you're learning Go, you probably aren't going to learn about how things are done in Java or Python or JavaScript or any of those other languages. But when you do explore a little bit and see how these other languages do things, you'll get to see alternative approaches. And this can be really, really helpful in helping things sort of resonate with you and understanding why things are done a certain way. So in this case, we have a React component. And again, you don't need to understand this code, but React is a front-end JavaScript library that allows us to render sort of dynamic components on the page. And this one is showing a friend status. If I recall correctly, it just sort of shows you if your friend is online or offline in like a little chat app. So in here, the two pieces of code that we really need to focus on is the component did mount and the component will unmount function. And really all these two are doing is the first component did mount is what happens whenever the friend status item gets rendered on the page. And then the second one, the component will unmount, is the function that runs when it's getting taken off the page. So if they travel to a different page on your website, that part might run. And the big key thing here is that these are two separate functions, so there could be a lot of code in between them. They don't necessarily have to be sitting in this friend status class together. So at one point, React decided to introduce these things called hooks. And this is the same code that we just looked at. The component will mount and the component, or will unmount and the component did mount, except this is a use effect function. And inside of here, there are two parts. The first part is the code that runs when the component mounts. Then the second part is we return a function that cleans up this specific, whatever we did in this use effect. So in practice, this doesn't actually work much differently than the first version we saw. But what's nice here is that all of this code is grouped together. And what this ends up meaning is that in the first version, we had two functions that could get spread out by a bunch of different code, and it could be really easy to forget to clean something up. But in this version, because you set something up and then instantly return a function to tear it down, it's really easy to remember to clean everything up properly. So when this was introduced to JavaScript, it was a little bit weird to some people. And you're probably wondering, why are we looking at JavaScript code right now when this is a Go talk? So this was actually a change that made a lot of sense to me, not because of my experience with JavaScript, but because of my experience with Go. So in Go, it's actually quite common to write code where the first part of the function actually sets something up, and then you return a function that is used to clean up or to stop a timer or to do something similar. This happened a lot more in testing. It's a little bit different now that testing has a cleanup function, but the same type of thing happened a lot there. And this pattern was something I was familiar with. But if I'd never used Go code when they made these changes to JavaScript, I'm not sure it would have made as much sense to me. So this is where looking at how other languages do things can sometimes have the unexpected effect of making it really easy to understand new things in the future. The next piece of advice I have is to not overplan. This happens a lot when we're really focused on a specific end goal. People will look at every tutorial, every course, every resource for learning, and they'll try to pick the ones that get them to job readiness as fast as possible. So if they want to learn React and Go and microservices and a couple other things, they'll look at tutorials and they'll try to find the ones that put all those things together. They'll try to find the tutorials that only cover those things, and they'll try to make sure they don't overlap too much, and they'll spend all of this time planning the best route to get to where they want to be. But I don't think this makes a lot of sense. Imagine that you wanted to get in better shape, and think about how you might go about planning for that. Whether it's you want to lose weight or you want to exercise, whatever it is, if you want to run a 10K, anything like that, you might spend weeks or months researching diets, workout routines, which equipment is the best. You might try to figure out what's the best gym in your area, who the best personal trainer is. And you could really spend a lot of time trying to figure this all out to find the best way to maximize your time. Or the other option is that you might just go to the first gym or find the first workout routine that you think makes some sense. Maybe spend an hour researching to figure it out, and then give it a start. Give it a try and see if it works. Excuse me. And if it doesn't work, you can always make changes. So as long as you get started, that's what you're focused on there. So if you compare these two approaches, it's pretty easy to ask yourself, which one do you think is going to be more successful? And in my mind, the second one is more successful every single time. That person has already got started exercising or dieting or whatever they're planning on doing, and they're going to have a lot more progress to show than the person who spent weeks just trying to figure out the optimal route to get there. And what's worse is the person who started with the trying to get the most optimal route is very likely going to give up before they even start dieting. Instead, they're going to focus so much on planning, and then they're just going to eventually be like, well, I did all the hard work. And then when it comes time to actually exercising or dieting or whatever else they need to do, they're not going to do it. So planning a little bit is okay. Like I said in this example, it's okay to spend an hour researching gyms or just finding out what your options are. But planning how to learn to code has diminishing returns very quickly. You can't really tell which courses are going to be well made, which courses are going to fit your learning style, and which ones are going to match your current skill set without trying them out. You can't easily plan the optimal route because a lot of these things are going to kind of depend on what you learned in other courses, how well it sunk in, and it's just not worth the effort of sitting down and trying to overplan that entire route from beginner to professional developer. So rather than spending weeks trying to research and figure out which programming language is best for your career, your salary, which technologies, or all that stuff, instead, I think you're a lot better off just picking something that resonates with you, something that seems like it could be a good fit, and giving that a go. So in the end, it's more important to actually be doing the things, learning to code, practicing, than to be planning. And one thing that needs to be made very clear here is that planning to learn isn't the same as learning. And I think this is really where the problem lies. Planning feels productive because it feels like you're taking real steps towards meeting your goals. It feels like you're actually putting in the work to learn how to code. But in reality, you could plan your route to learn to code for a month. And at the end of that, you still don't know how to code. You don't know how to do anything at all coding related. So you aren't getting the results. This happens with businesses and other things all the time. People will dream of building a startup and they'll plan for all these cases in their head and how this business is going to work at scale and all these little things. But unless they actually sit down and start building the business and start trying to sell whatever they're selling or doing whatever they're doing, the business never actually takes off. So coding is the same. We can dream and we can plan, but that all has to be within reason. We need to eventually sit down and start putting in the effort and the time to learn to code to get those results. So this usually leads to the question of, don't you make courses? And isn't this bad advice for that business? And a lot of people ask this because it would seem optimal for me to tell people to research courses and find the best one. And then hopefully they'll think that's my course and they'll start using those. But the truth is, I think people are better off just picking something that seems decent for them and getting started. I would much rather see people dive in and learn through another course than to have them spend weeks trying to research the best course, decide that it's my course, but then get frustrated and quit. I want to see people learning to code with Go. And I think the more people that are learning that, the better it is for myself and everybody else creating courses and learning material, and for the whole community, the Go community as a whole. So this leads to my next piece of advice, which is to practice, practice, practice. And this is another reason why I don't think it's a big problem if people just pick the first thing that seems to work for them and work with it, because it's going to take a lot of practice to learn how to code. And you shouldn't just be following guides. You should be building and practicing and trying to leverage what you're learning. So Gopher Sizes is a course that was mentioned by Vladislav. And I'm sorry if I butchered that name, Vladislav. It was designed specifically around a series of 20 exercises. And in each exercise, I recommend that people try to code as much of them as possible. So there's a little video that'll sort of introduce what we're trying to do, whether it's building a little quiz game or building a deck of cards or something along those lines. I'll try to explain what we're going to do, and then you can take a break and go try to code as much of it you can. And then afterwards, you can come back and watch a video of me coding the whole thing. And the whole series is focused on just getting something working. It's not focused around perfect code or anything like that. It's just getting your hands dirty and working on some projects and getting some practice in. But even with resources that aren't designed specifically around doing these practice projects, you can still take the same approach of practicing multiple times. So if you're following a tutorial, you could try to build something similar afterwards without looking at the tutorial. I do this all the time when I'm learning new technologies. I'll look at how somebody suggests to use a library or whatever it happens to be, and then I'll go try to build what I need to build using that library and what I learned to see if I really understood what was being told or what I was reading or what was being told to me. Or if you're taking a course where you build one big project, say, for instance, you're going through a course that teaches you to build a Twitter clone, you could instead go through the course and try to build a Pinterest app next. And this works really well because you can try to do the application on your own, but when you get stuck, you can reference the course materials and get a feel for what their next steps were and what maybe your next step should be based on that, because it tends to be that these applications are similar enough that you can sort of use the course as a guide to get you through it. Another option is to expand what you're learning in the course. So if you take a course of some sort and it uses OAuth to log in with Google, maybe you can see if you can use another OAuth provider like Facebook or any of those others to log in. Another example of this would be like HackerRank problems. Whenever you're doing those, you might get a solution that works your first try, but you can come back and try to write a second solution. Try to think if there's another way you could approach this problem, or if you could structure your code a little bit differently, and just to see which one seems a little bit faster or which one's easier to read, and just see how these different approaches all compare. Even if you're just working on personal projects, you can still take this practice approach by going back to old code and seeing how you might improve or refactor it. Chances are, if you go back to code you wrote 2 months ago, you're going to see a drastic difference, and you'll think, man, why did I code this way? I could change it, just a little bit and make it a little bit better. And this is also really good for helping you reassure yourself that you're actually learning, because day to day, it's really hard to see those steps. But if you go back a couple months, it's really easy to see the improvements you've made. Similarly, with old projects, you could try structuring them differently. Or if you didn't have tests, you could try to add some. Or if you had tests, maybe go back and explore how would you test differently now that you understand the application as a whole a little bit better. And all of these things will help you become a better developer. So don't just follow tutorials. Don't worry about perfect code. Just focus on improving a little bit through practice and revisit things you've done in the past to see if you can improve on them further. This next piece of advice is to learn with others. And I get that this one's not always easy to do, especially now, but meetups like this are a great place to start. Another way to start is study groups. There's lots of different online study groups that you can usually find. And these will help you solidify your understanding a lot more, because what generally happens is that each person in the group will ask different questions, and you can chime in when you know the answer and try to help somebody understand it. And often you'll have a unique view on how that thing works that's a little bit different from how you learned it. And you can share that with the person, and it'll often help it really resonate with them. And the same thing will happen. The other people will help you see things from their perspective, which might be a little different from how it was taught in the tutorial or the course or whatever resources you're using. And it can sometimes help you really understand them a lot better. Another benefit to a study group is that it can often create accountability. So if you're with a group of 6 kids, or not kids, but 6 other students, or whatever it happens to be, and you're all going through the same resources, you don't want to be the one who didn't finish the work. So you'll find time for it and be more accountable. This is one of the reasons why universities and schools of that sort tend to work pretty well, is that a lot of students are accountable because they can't just do it at their own pace. Other ways to work on this, learning with others, could be to join a forum or a subreddit, to join the Gopher Slack. And if you can't do any of those, or if those are a little bit more challenging, another way to do it is just to write a blog summarizing what you're learning. This isn't quite the same as learning with others, because you can't interact with people and you won't really get their other people's insights. But I do this all the time to help myself learn. And I find myself referring to my old notes and my old writing all the time to learn how something works. And that sounds silly, but I'll use the technology and then not touch it for 6 months. And then I'll come back and be like, man, I don't remember how this works, but I happen to write a little bit of a blog post or some notes for it. So now I know how it works. And usually I'm pretty good at explaining things to myself because I think the same way. So this works pretty well. So that's it. Just remember that the journey before destination. If you focus on the journey, you'll end up learning a lot more, having more fun, and you're going to be better prepared for the future than if you just rush to the end. Thanks for listening.
Okay, thank you, Jon, very much for this wonderful presentation. I would just like to ask any questions. If you have any questions, just please put them into the chat. We can answer them. Jon can answer them. And if that's not the case, I would like to take over from here. So let me just share my screen. Okay, so I hope that you see my screen. So I would like to present today my Go journey. I would like to be much more specific than Jon is. I've been a Go developer for 2 years, and currently I'm working as a software developer at Nexam. And I would like to show you the steps that I made, the libraries that I've seen, which courses I attended, which courses I think are good, at least for start, etc. And then I would like to show you a short demo of my process of learning. It's I kind of didn't want it to be a telephone book, but it ended up like 4 of them. So I hope you won't get bored like halfway through it. So first thing I would actually like to start with is how I come to learning a programming language. And I think learning a programming language is kind of like building a building. So I think we have here like 3 main pillars, or at least for me, it's like that. I do quite a lot of reading when I'm learning new programming language. I access some courses. As Jon said, it's very good to go to the courses just to try them out and not really think about it too much. I see a message in chat. Okay, so there is a question to Jon in chat. So if you may want to have a look at it, please, or answer it after that. Thanks. Anyways, so the second thing, as I said, is attending courses. But I think the main interesting thing and the main point for me as for learning is talking to people. Because when I talk to people, either people who are more senior than me, or I do some pair programming with people who are on my level, or even when I mentor people who are on more junior level than me, I learn quite a lot and I really need to think about stuff at that point. So that's very important for me. But you know, what would be a building without a roof? So you need a roof, and that's the most crucial point here. You need to be writing code. You can do as much reading, as much of the courses, talking to people as you want, but if you're not writing code, you don't really learn a programming language. You really start learning it when you're writing. And these pillars just support your writing. So I think that's the point, and that's how you can access this whole problem of learning a programming language, how to think about it, or at least how I think about it. So now I would like to be a bit more specific. I would like to go over Go libraries that I've used over the 2 years, or at least some of them. I have here this slide. Yeah, it's quite a lot of libraries here. I have them sorted from internal to external, from left to right, and then from top to the bottom as I've encountered them or as I've used them. So you can see these are more than 2 years of development, and it's not definitely something that I learned in the first 2 weeks. So don't think about learning stuff as just learning. Think about it as doing some new stuff and finding things along the way. So let me just mention a few of those, or quite a bit of those, because I think that it's nice to go through them to point out what is interesting, what is important, and how it can help you. So of course, here at the top left corner, you have FMT and then strings and bytes libraries from Go, from the internal library. And those are the ones that you will most probably encounter as the first ones, because you will do hello world and you will do some nice small exercises. So you will probably work quite a bit with strings, with byte slices, do some printing and stuff. So you will probably encounter this one very soon in your career. Of course, you need to then handle errors. So we have the errors package. And the one that I want to really point out is the testing package, because testing in Go is very clear and very easy. You can write test functions very easily, and you can even write very cool and very powerful benchmarks. They're directly built into the code. So I think that's something to really give a try and to have a look at. And then, of course, I'll jump to this net/HTTP, because if you're writing Go, you will most probably write web services sooner or later. And for writing the web services, you need to do some HTTP communication. So you will go through this net/HTTP package and write some services using that. Then another interesting one, or important one, at least from my perspective, is the sync package and sync atomic, because these ones arise naturally when you start doing Go routines. When you're working with Go routines, you usually need some orchestration or need to check if they're running, need to protect the resources from data races. So that's when the sync package comes in, and it naturally comes to you and you just learn it as you write your code. And the context package is basically the same. It really comes to you when you want to check your flow, check how your Go routines are working, stop them or signal something to them. So that one is very tightly connected to the sync package. Then, of course, it comes to more specific packages like regex or database, depending on what you're using in your project, or encoding, sorting, etc. Another one I want to point out is this template one, because you might have already seen it when you're starting learning Go and you, for example, written Helm files or something like that. You already know the Go template language, and it's used through multiple projects as I've seen it. And it's really, really interesting to have a look at it, because it's quite powerful and quite interesting. And the package that I like the most is this reflect package, because it's kind of a way to write generics in Go. But that's not the main point of it, at least for me, because as for this reflect package, I usually view it as a great way to learn interfaces and how interfaces work and how they're represented in memory. Because when you start working with this package, and you just read about it and try it out, you really understand how interfaces are represented in Go and how memory is represented in Go to some extent. So I really recommend you checking this one quite soon in your career. Yeah, then I have these two, and they came in Go 1.16. That's why I have them almost at the end. So these two, FS and embed, are quite interesting, and I think you in your list will have them much more earlier than I do. And then I have this flag package, and that one should be almost at the top, to be honest. But I used other ways to inject information into my services. So I didn't use this flag package. I used other dependencies. So that one is very nice when you're just getting started. For the external or more external dependencies, you really want to have a look at the Go tool. Go tool is how you run programs from command line, for example, or how you process them, how you run tests. So you either use it like built in from your IDE, or you run it from your command line. And it's really important to know how to run it from the command line. For the external ones, I think like the most well-known here are the stretcher/testify, which kind of gives you another layer or makes tests more comfortable, because it makes asserts really nice and easy. So that one is used almost throughout the Go universe. It's used, I've seen it almost in every project I've been on. Then there is this map structure. That one is interesting as well, because it allows you to seamlessly get from maps to the structures and back. So that one is really useful if you're working a lot with maps. If you have some, for example, library that uses maps and you want to map them onto your structures, you might want to check this out. Then there are some quite specific ones, some logging packages, and another, or well, almost the last one I want to point out is this Go Delph. And that is a debugger written in Go for Go. And it's very, very powerful. And it's probably built into your IDE when you're working in Visual Studio Code, or if you're working in Golang, you most probably use it and you don't even know about it. But it's very nice to have a look at it. It's very powerful. It's got a very nice CLI. And you can use it to debug not only on your computer, but even remotely on cluster or somewhere else. So it's really worth checking out. And the very last point I want to point out is this X, which is for experimental tools, but it's still kind of internal library. Those are packages by Go team that didn't make it into the internal library. tool/present, because that's what you're actually watching now. This presentation is written in this present tool. So this is it for the libraries that I've used over the 2 years, or at least the most important ones from my point of view. And now I would like to get to this demo where I would like to show you how I learn, how I view the process of learning. So let's see if we can solve this task that you can see here on the screen. So we want to write a program that counts a percentage of a specified letter in all files in a directory. So we want to go through the files in a directory, and we want to count for each file the percentage, for example, of an A in that file. So how would I approach this project personally? So at first I have a look at the task and I try to find what is the core functionality there. And the core functionality you can see here is that we are counting a percentage. So we cannot avoid that. We need to write that. So we start most probably with a function like this, and let me copy this to the IDE because it's much more readable there. So we start by writing a function like this, percentage, that just gives us a percentage of that letter in our input, which we, at least for now, take as a slice of bytes. I don't want to go through the code, it works, but of course, when you're writing such a code, you might think about testing it, and you might want to write a lot of tests or even a benchmark to try out that function, or if you write more performant function, at least from your point, try it out if it is really more performant. So this is what I would be actually doing next here. But that's not what I'm planning today, because today I want to really write the program that we have been assigned to, or fulfill this task. So what we'll do next is we will write the very first version of the main functions code so that we can run our program. And I'll again copy this one over. And you can see that we've written quite simple main function. We have here two constants, requested letter A. So that's the letter that we were counting. We have this data directory with all the data files that we want to go through. We just read the directory, load the files that we have in that directory. We join the data directory with the file name. We read the whole file using this OS read file. We might do some error handling here, and then we count the percentage and print it. So it's a very simple program, but you can already see how we're learning here, because you can see that to write this, we had to either Google or ask people or read something or go on a course to find out that there are these functions, for example, OS read file for reading files, or OS read there, path join, all these things. So we are already learning by this time that we've written the first version. And I would like to run this just so that you can see that it is actually running. So let me open here a command line, clear it. And now I'll just run this like this, very simple run. And you can see that we are counting. And the numbers seem fine. If you see these files, this is just A's, this is just text hello world, and this is a very long file containing a lot of lorem ipsum text. So this looks that it works and we like it, but now we start asking questions. And I think that asking questions is the most important part of the process of the learning, because when you're learning and you're curious, you learn more actually. So this is something that Jon already mentioned, that if you're working on your project and you just have a look at it again, you can see that you could improve something. So if we have a look at this, we can see that there are a few things that we can improve, or at least we can start asking questions. So we have this requested letter here and his data there, but that's not really general, is it? We are counting A's and we are counting them in some specified folder. So that's not something that we might want from our program. We might think about a process, how to do this more generally. So that's like our first question when we're curious enough. If we can get this information from the user. Another question that would come to my mind, and it really depends on how senior you are, at least this question, because when you are senior enough, you might have some ideas about the memory and stuff. When you are junior, like complete junior, you might not be aware of this. So this might be a more tricky question, but we are at this moment loading the whole file into the memory. And if it's a big file, and if we are then, for example, running it concurrently or something, it might be a problem in the end because our program is taking too much memory. So we might be asking if we can avoid this, if we can avoid loading the whole file to memory and just process it as a stream of bytes, because that's basically what we're doing. We're going from the start till the end, so we don't need the whole file at one point. Okay, so that would be our second question here. And of course, we're writing Go, right? Everyone, when he starts using Go, he wants to make everything concurrent because that's what's Go about. Yeah, I have Go routines, I need to use them. And I actually kind of want to warn you against that, because when someone new comes to Go, they tend to overuse Go routines. And I feel like sometimes Go routines are not even necessary. You might want to write some benchmarks to find out if this is really the bottleneck, if you need to parallelize that, or you might want to really think how many Go routines you need, etc. So this is a question that is interesting and we will answer it, but you might want to think about it more when you're working on your projects. So the first thing is we ask if we can get the variables from the user. So we probably start either Googling, asking people, as I've said, going on courses, something. And we learn about this flag package, which is a package in the standard library. And we can do something like this. And let me just copy it over to the code as well. We can load the flags from the user. So we just write flag string. It's quite simple. You actually write the name, you write the usage, and it's very straightforward. And you're just learning stuff because you've just Googled for stuff, found something, you've used it. And now you see how it actually works, because when you use this, you see that there we have a problem. There is some problem. And if you do some more investigations, reading or just debugging, or like scrolling over this because it tells me that, you see that we have a pointer to strings. So we need to unpointer it here. And of course, we might think about solving this somehow because, yeah, like you can ask, can this pointer be nil? Because if we're dereferencing nil, then of course it's kind of a problem. So we might think about this more, and it brings more questions, but I will just stop here as for this question, and I will try to run it and show you how this is ran. So we can now do something like go run dot, the same way as before. And now we can add our flags, our nicely defined flags here. So we can do D, give it the data folder as we've done before. And then we give it the letter. So if we run this, you can see we have the same result. So we've improved our program. Objectively, this is improved. And we've learned something. So we can just try it with B, just for fun. You can see that we got another number. So it really, really works. Most probably, right? But it works. And we've learned something new. But we don't stop here. We want to answer all our questions. So the next question that we have is if we can avoid loading the whole file to memory. And as I've said, this one is a bit trickier. We need to rewrite our percentage function because that one is actually the one that takes a whole slice of bytes. So it takes the whole file at the moment and goes through it. So we might want to rewrite this one. And if we search or talk with people again, if we try solving this problem, we find out that there is something like IO reader, which is an interface that gives us a stream of bytes. And we can read from that. And if we do some more, we can of course try using this interface by itself. But if we do some more searching, we find out that there is something that is even more useful for us because we want to actually read it here byte by byte. So we can wrap this reader by using buff.io new reader, which gives us something that reads the data as buffered input. So it doesn't read the file really byte by byte, but it buffers it for us, which makes it quicker and more convenient. And even more convenient by the fact that we have this read byte method now. So basically, as for the calculation, it doesn't change. We do the same calculation, but we've changed this approach to the file. And now, as you might already think about, we have this problem that we are calling percentage with slice of bytes at the moment. So we don't want to read here the whole file. So we will change the main function here. And let me just replace the right part. And you can see here that we changed it whole, and we see here this OS open. So we are learning other new things. We are learning about OS open, that we get a reader here. Then we are passing this reader to percentage. We are closing this reader because it's not just a reader, it's a read closer. We need to close the file after we've read it naturally. So this is our next improvement on our way. And it shows us how we can improve our program and learn with it again. So if we run this, you can see that again with 4B, we got the same results. And the last thing I want to show you is how we can answer this question. Can we make this concurrent? So of course, let's say I'm very new and I start doing like something like this, go func, and I just want to make this as parallel as possible. And I really want to tell you that this is not a good idea. So I do something like this, and this is the first thing that I run. So I run it and it doesn't do anything. Again, that's learning. I did a mistake somewhere and I need to learn what that mistake is. So I might do some debugging, I might do some searching. And in the end, I find out that the Go function needs to take this file as a parameter because the for loop runs quicker than the Go functions are able to start. So we just get the last name of the file. No, this is another problem. Sorry, this is that the for loop runs too quick and then the program ends, which ends basically all the Go routines. So we will learn about wait groups, and we can do something like sync wait group. And you already see that we started using Go routines and we need to do sync package. So we are doing wait groups and we're adding to this wait group 1 here. So that's the number of Go routine that we are running here. We're in every iteration running 1 Go routine. And then in the end, we do wait group dot wait, which waits for the Go routines to finish. But we need to signalize to the wait group that we're finished. So we do this differ, another nice word, right? We're learning that. We do differ WG done. And when we run this, we get another weird input. And this is another mistake that we can solve. And this is done by the fact that we are not passing the file here because the for loop runs too quickly. And in file, there is only the last item in files. So we need to pass this file every iteration into the Go function. So we can do something like this. And now we can see we don't have that problem. And if we run it, the numbers seem to be fine. The numbers are the same as before. So we fixed 2 problems. We've learned quite a bit about concurrency, at least for if you're a beginner. So this is nice, but you know, you're spinning up an unlimited number of Go routines and it's not really something you want to do. So here on this slide, I just have an example how you can limit the number of Go routines. Here we are limiting it by runtime num CPU, which is number of CPUs or threads on your computer. But you can use another numbers. You can run more Go routines if you have an operation that waits a lot for IO or so on. So you can really think about it, you can benchmark it and learn new stuff. But as I'm almost running out of time, I need to get back into the phone books. So the first phone book I have here for you is this phone book of learning resources. And the place where at least I started, and I know that a lot of people started there, and it's a great place to start, is this Go tour. And it's a tutorial done by Go team that really brings you from the I'm not knowing Go at all to I saw the language. I saw quite a bit of features of that language. So this is a great place to start, at least for me. Another web page that I love is this Go by example, where you have examples of usage of you quite often used function like from sync package or timers, etc. Every time I forget how something is done, I go here and I find it. Yeah, I don't think I need to talk about gopher sizes anymore or Jon's blog, because that has been mentioned quite extensively. Exorcism was mentioned as well. So I'll jump right ahead to this Arden Labs and they're training Ultimate Go. This is a course and I've been there personally, but they make them online as well, or you can buy that course and just go through it in your own pace. And it's really something to go over when you're already writing Go for some time, for example, half a year or more. because it really shows you the intestines of the language. It shows you how the things are done, how, for example, garbage collector works, how scheduling works. And it's really, really interesting. And it's a great step if you want to become more senior and understand more what you're actually doing. And there is another course from Arden Lab that I haven't mentioned, and that's Service Go. And that just shows you how you should write, or how it's nice to write services so that they're robust. They handle all the panics, all the errors, they do logging. So these two courses are something that I took and I really like. If you're more into books, you can just try the Go programming language book. It's quite old, it's from 2015, but the core principles are still there. The core principles about interfaces, about all the stuff, shows you the internal packages. So it's still quite a good resource, even though it's getting a bit old. If you're more into videos, you can try this Just for Fun YouTube channel, where Francesc Campoy shows how he does things, how he approaches problems, and he actually solves real life problems. So this is an interesting one. If you're more into theoretical things, there is a blog by Dave Cheney, Acme of Foolishness. He's one of the most respected people from the Go team. So this one is worth a try as well. And another courses that I think are quite good or very good are the ones from Bitfield Consulting, from John Arundel. So this is a short phone book from me because I don't want to overflood you with too many resources. Another thing that I want to talk about is the community, because I think the community in Go is very, very strong. There are groups for underrepresented people, for example, Women Who Go or Go Bridge. There is this awesome podcast that John already mentioned, Go Time Podcast. And as for me, I like to take information from Twitter because there is a lot of new hot information there and you can just get to it very soon. So there's official Go channel. There are people from Go team or Bill Kennedy who does these courses on Arden Labs, other people. So Twitter is for me the place to go when I want to really learn about the hot things. I just wrote there these 3 names because they're very crucial for the whole Go community and for the whole language. Robert Griesemeyer, Rob Pike, and Ken Thompson. And these are the 3 people who are the original designers of Go. So if you see these names, you might at least know who they're. So they're very, very good. And the last thing about the community is that there are, as you can see, meetups, and there are very good conferences. And there is a link here in these presentations. I will have it later on my website, so you can access it there, or you can just see this recording. And the most interesting or biggest conferences are GopherCon in either US or Go Lab in Italy. So I was to GopherCon and to virtually this year, and I was in Go Lab personally, and it really gave me a lot. So I recommend going to these conferences as well. Okay, I'm getting to an end, but one last phone book, because you cannot write Go without looking at the gophers, because the gopher is really, really crucial, and it's really bound with language. It's this iconic mascot, and you might want to know something about him, right? So you can just go to blog Golang.org, which is the official blog by Google, and read about him. Or you want to look like a gopher. There is this awesome website, gopherize.me, where you can create your own avatar as a gopher. So that one is really, really nice. I like it. Other thing that I really like, and most people, I don't think they are aware of that, is that there is a model sheet by René French, who is the author of Gopher. And in this model sheet, you can see how gophers are actually supposed to look and how they're supposed to hold things. And it's very funny. You should have a look at that as well. And if you're into writing Go for some time, you might want to get a plushie as well. Or, ask your grandma or girlfriend and they can knit it for you. Okay, I think I've gone through all my phone books. So thank you very much for listening. Thank you for your participation. And if you have any questions, just put them into the chat. And I would like to open here a discussion about your principles of learning and about the resources that you liked personally. So thank you again for attending and join us for the discussion.